Welcome along, ladies and gentlemen, today to the SETI seminar series, the last one for 2008, and we hope you enjoy this one. We think it'll be a very interesting topic today. We've got three fantastic speakers here to talk as a panel on the nuclear weapons and space weapons. Pavel Podvig currently works at Stanford University. He's a graduate of the Moscow Institute for Physics and Technology and the Moscow Institute for World Economy and International Relations as well. He has a PhD in political science from that institution. And he is also on the board of directors for the Bulletin of Atomic Scientists. And he's going to talk to us today about strategic arsenals around the world. The man in the middle will be familiar to everybody. Pete Worden is currently the director of NASA Ames, and he's an acknowledged expert in many fields, and particularly we're utilizing his skills in the space weapons field. He has a background second to none in that area as a retired brigadier general in the U.S. Air Force. He's also an ex-professor at the University of Arizona in Tucson, and he's a graduate of the University of Michigan and University of Arizona. And to complete our panel, we have Will Marshall. Will's a graduate of Oxford University in the UK, where he did work on quantum mechanics, and he is also familiar to those of you who are long-time observers of the SETI seminar series. He spoke back in May, and he's also interested and is a great advocate for the de-weaponization of space, as you'll hear in his talk today. So we're going to start off with Pavel. We'll have 15 minutes for each speaker, and then at the end we're going to have 15 minutes of time for questions and discussion amongst the panel and also from the audience. Thanks very much.
Thank you very much, Adrian, for inviting me. Thanks for coming. What Adrian asked me to do, and I thought is to give an overview of the nuclear forces of around the world and the trends and status. And I'm myself more of a Russian strategic forces student. Sort of, I study Russia more than others, but I thought that I could try to do what I can and give you the idea of where we are in terms of numbers and in terms of policies and problems that all these nuclear forces currently experience. These are the numbers, the estimates, and the best. I plug the Bulletin of the Atomic Sciences. This is a nuclear notebook, a regular feature in the bulletin that is run by the Natural Resources Defense Council. And they provide periodic estimates of the arsenals. And this is where we are. Russia is currently leading the pack with more than 5,000 nuclear weapons deployed, and the total number is estimated to be about 14,000. The total number, and we know these numbers for Russia and the United States, or at least the estimates for those, that would include pretty much everything that is sitting there in some kind of assembled fashion. Some of those warheads in those 14,000, they are sitting there awaiting dismantlement. They're waiting to be taken apart. So they're not really kind of a part of an operational force or reserve or anything like that, but still they are there as physical warheads. I'll go to the details of each country later. So next, the United States is the second best in this chart, with more than 4,000 nuclear warheads still deployed. operationally, and about 11,000 warheads total. As you can see, the rest of the pack is much smaller. France is the next contender with just 350 warheads. China, United Kingdom, India, Israel, and Pakistan. They all in this kind of a. But still, it's a substantial. If you look at that, these are substantial numbers. We're talking about tens of nuclear warheads, and so they are getting there to the five sort of formally acknowledged nuclear states. And North Korea is the ninth nuclear weapon state. There is basically, it is believed that it has the material for a few nuclear warheads, but the best estimate that it does not have an operational weapon actually deployed. I'll start with the United States as a host country, although Russia is the leading in terms of numbers. And this is the what the United States has at the moment. There are a little bit under 500 Minuteman III missiles. These are ICBMs, and most of them are carry 3 warheads each, and some of them are currently carry just 1. So you have the 750 warheads total. The plan is to reduce that force slowly to 450 ICBMs. That was the latest word, and it is possible that the new administration will the new administration will actually will have to do the nuclear posture review in I think in 2009. That's congressionally mandated, and that could change the composition, and that could change the numbers. But the results of the last nuclear posture review say that the United States will keep 450 Minuteman III missiles in silos. Submarine force, the future is easier to predict. I think the plan is to keep 14 Trident II submarines in operation, and I don't think that would change dramatically with any kind of review. The United States traditionally keeps emphasis on its the submarine-based ballistic missiles, and that's the, if anything will be left, that would be the 14 submarines. There are 4 more submarines, but they were converted to other missions, to cruise missiles. And there is a bomber force, which includes 72 active bombers, and those are the old B-52s and the newer stealth B-2 bombers. And these are, I believe that B-52s are also dual capable. B-2s certainly are dual capable. They can deliver. And they basically mostly what they do is that they are involved in conventional missions. And the United States still has some tactical or non-strategic weapons, which are not the kind of the strategic kind by definition. And these are mostly sea-launched cruise missiles, but none of those are actually deployed right now. They are all sitting in storage on the shore, but there is a capability to redeploy them if necessary, although that would take some time. There are some bombs, and the total the estimate is that the total number of tactical warheads is about 500, and about 100 of those are outside of the United States. About 100 of those are deployed in Europe, and that's actually a contentious point with Russia in particular, because that's the politics of those weapons is fairly complex. So let's go to Russia, and as you can see, this is a bit busier chart because Russia has a variety of systems, and it is now in a transition from kind of old force to new force. And the core of, if the United States relies primarily on its nuclear submarines, Russia traditionally relies on its intercontinental ballistic missiles. Now there are 415 operational missiles. The last number that the rocket forces cited, 96% of those are in high state of alert, so they are ready to go in a few minute notice. But the composition, I mean, there are a number of old missiles which are getting close to the end of their operational lives, and SS 18, 19, and 25. And Russia is working on deployment and development of new missiles. With old missiles, it is interesting, and you may appreciate that it turns out that these things last forever. Just a few days ago, they announced that they extended the lifetime of the SS-19 missile to 33 years. So, and it's sitting there in a silo fueled with these the UDMH fuel, and so that's quite an interesting fact. The new missiles are solid propellant missiles. SS-27 Topol-M, the Russian name, and RS-24 is another new missile, but this is just a multiple warhead version of SS-27. There are there are some submarines as well. As you see, the fleet is 13 submarines. However, most of them are old, and there are some Delta 3s and Delta 4s. Those are old Soviet-built submarines, and Delta 3s are really old. They are actually retiring, and Delta 4s are the 6 submarines will stay in force for some time, maybe for about 10 or maybe even 15 years. And Russia is working on a new submarine. It's not yet part of the force, but it is there. It's getting there. It's in the sea trials. And it is building a new sea-launched ballistic missile for that submarine, the Bulavan missile. It's a new solid propellant sea-based missile that will be deployed on those Beret submarines. That program, the Bulavan development program, wasn't going very well. The missile just had about 9 flight tests, and I think only one. They said the last one was the first that was completely successful. They had hitches or even failures in most of the tests. And the bomber force, Russia keeps 2 types of bombers, the older turboprop 295s and the newer, or they are also old, these are from the 80s, the Blackjacks, the supersonic heavy bombers. And Russia is actually will be building new bombers, new Tu-160s. And as you can see, Russia has a fairly substantial non-strategic arsenal, and that again includes sea-launched cruise missile, some bombs, some anti-ballistic missile warheads. The estimate is that it's more than 2,000 warheads in that arsenal. But as far as I can tell, the best estimate is that these warheads are tactical weapons are consolidated in what's called centralized storage sites. So they're not really there deployed with any troops. They are sitting in a storage, although they are ready to be deployed. Final point on Russia. The way it works in Russia, what's happening, as I mentioned, Russia is building new missiles. It's building new submarines. It restarted the bomber program. So what will happen in about 10-year time? Russia will actually reach the point where its strategic force will consist of primarily of new systems. So, and that would be very difficult to reduce that force substantially, because these are new missiles. So there is a bit of resistance in Russia will be quite a bit of resistance to doing that. So we are, but at the same time, this modernization program is going ahead full speed. And others are easier in many ways. France relies primarily on submarines. Again, this is the choice for many countries. And it has 4 submarines with ballistic missiles, and it is building a new ballistic missile that would be deployed on those submarines or newer submarines. But I think in France, and France also has some bombers. So it is a force about 300 warheads, and I think France will have made the decision to keep it at that level, and it could probably go a bit lower in terms of, but only, I guess, in terms of kind of operational deployed warheads. And it may at some point emulate Britain, which did very interesting thing with its arsenal. Britain has only submarines. They got rid of all the bombers and everything else. And they have 4 submarines. They use Trident II. They use U.S. missiles on those submarines. And they lease them, actually, as it turns out. But they declare that at any given time, there will be only 1 submarine on patrol with 16 missiles and no more than 48 warheads. So that's the policy. That was a big review a few years ago, and that's what the British, they decided that this is what they don't really need more. And that's that's a good step toward actually getting rid of weapons. But as it happened, about 2 years ago, there was a big debate in the UK whether they want to keep the Trident II force because of they had to make this decision because whether they will be building a new submarine or not, and they had to start early. And people actually did talk about an option of just getting rid of all nuclear warheads in Britain. But eventually the kind of cautious, quote-unquote, faction prevailed, and the decision was made to keep the Trident II force. But then again, so Britain is committed to an investment that will put it on a track to keeping those submarines for about 30 years after these new submarines will come into service. China is the last of the traditional 5 nuclear weapon states, and with China, the interesting story is that China for a long time relied on really handful of ICBMs. They had right now the estimate is that they have 32 intercontinental ballistic missiles. And but about 20 of them are the old DF-5, and these are old liquid fuel missiles. There are that are stored in basically in caves in very underground complex, and they are not kept in any kind of a state of alert. Some estimates say that they are actually the warheads are stored separately. But China was reasonably happy about this kind of a posture. Now they are building new missiles, and so these are DF-31 and 31A. These are solid propellant missiles that are mobile, and we will probably see some modernization, but I don't think that it will go much higher in terms of numbers. China is also building submarines that would carry ballistic missiles. Right now, it doesn't have any operational, but it is building 2 or 3 new submarines. And it also has a number of non-strategic weapons. And unlike other countries, it has intermediate range missiles that can carry nuclear warheads. And the United States and Russia are prohibited from having these kind of weapons because of the Intermediate Nuclear Force Treaty of 87. So Russia and the United States cannot have missiles with a range of more than 500 kilometers and less than 5,000 kilometers. That's the bad. And finally, we have other nuclear weapon countries that are not kind of recognized by the Non-Proliferation Treaty as the nuclear weapon countries, but they have nuclear weapons nonetheless, and they are in some ways they are similar in what they do. They rely primarily on aircraft and short and intermediate range missiles as a primary means of delivery of their warheads. None of them has intercontinental range missiles, and I think again, but all of them, Israel has a reasonably intermediate range missile. It is not probably working on intercontinental range missiles. And India and Pakistan, they are working on they have fairly active missile programs that they go ahead with. And finally, North Korea, again, this is a kind of outlier here because they do have material for a weapon and for a few weapons, but they probably do not have any deliverable weapons at this time. Let me stop here, and if there are any questions, I'd be happy to answer them, whether now or at the end. Or okay, so we'll. Thank you.
Okay, I just click through these things. This is one of those Apple kind of products, right?
Or you can use just the space.
Okay, I'm very quickly going to go through space weapons, and I need to have a disclaimer. NASA doesn't have any interest in space weapons, so I'm not speaking for NASA. In fact, for the record, let me say I don't think we need any space weapons, although I spent a good bit of my career working on them. So, but that was a long time ago in a galaxy far away. So some of this information may be a bit dated. But this was, Will Marshall cut this talk down from about an hour, so hopefully I'll go through it pretty fast here. But I have to see which charts you left in and which ones you left out. He did leave that one in. But I really want to spend just a few minutes because and in fact, when I first met Will, we spent a lot of time arguing about what is a space weapon and space control. So let me kind of give you at least the current discussion. And I do want to point out that President-elect is said that he wants to do some rather comprehensive arms control on these. So I think this discussion will evolve over the next year or two. Talk a little bit about what's going on today and some sort of dual use kinds of things. In the about a decade ago, and slightly before, the U.S. DoD and particularly the Air Force got pretty aggressive and wrote a number of reports. This is there's the Air Force Strategic Master Plan, and there's some U.S. National Space Policy. If you read these documents, they look pretty ambitious. They talk about space dominance and moving forward. Whether that was advisable or not for the Air Force to do is an interesting point. I want to say again that these documents, you read them, you say, oh my goodness, there's going to be giant laser battle stations and so on in space and so on, but very little real stuff is being done. These were sort of sales and marketing pitches, quite frankly, designed to appeal to people that won't be in the White House much longer. They are interesting. You ought to read them, though, because they are a little scary. This obviously triggered a variety of discussions. And particularly, probably in the middle of the decade, there was a lot of discussion when these things came out. So there were a lot of articles, both in the U.S. and overseas, that said there was about to be a new arms race in space. In fact, again, that's where I met Will, and we argued a lot about it. I think we're probably in 90% agreement now. So it took a lot of booze. But also, as a result of this, Russia and China have been particularly vehement about comprehensive space weapons ban, and there's been a lot of discussion about that. Now, I have to say again, I think, particularly in the case of China, that was somewhat two-faced based on actions the last year or two. One of the most interesting documents is this annual Space Security Index that was originally sponsored by the Canadian Foreign Ministry and other groups. I think the last one is 2007 or 2008. These are very good documents, and I would commend them. And they give you a real idea of what's going on. Now, in the United States, there's a number of discussions, and this is where we really get into where do these things fit in terms of military space. And I want to emphasize the national security space program is divided into two pieces. One is spy satellites, which are managed in an entirely different manner, although there's been attempts to try to merge them, and military. But in the military side, most of what's done is in Space Force enhancement. This is basically communications, navigation, surveillance systems, and so forth that are designed to enhance our armed forces' ability on the ground. And so that's where you'll see like 90-some% of it. Counter space is where a lot of the argument is in the next two areas. And counter space really is divided into three areas. One is knowing what's going on in space. And I'll say that 90% of what is going on in counter space is in space situation awareness. Defensive counter space is how we keep our critical national security satellites from being destroyed. And by the way, again, I won't get into a lot of discussion, but my own personal advocacy on that is that we do what's called operationally responsive space. So if they're destroyed, you put them back up in a day, and then you go do something nasty to those who destroyed them in some other way. And but there is a lot of attention now on survivability of critical U.S. systems. And offensive counter space is where generally there's anti-satellite space control. Now, turns out most other countries don't have a lot of military space, so it's kind of a moot point. But there's a lot of discussion about that. Space Force application is the other area that there's a fair bit of discussion on. Nuclear deterrence, of course, is one area, and that's the ICBMs as far as the space community is concerned. But missile defense initially was highly focused on space-based capabilities. It's not so much anymore, but it's still a controversial area. And one that is potentially of some interest is conventional strike. There are efforts ongoing in the Department of Defense to make a conventional ICBM. The concern, of course, there is how do you know when you fire it at somebody that it didn't have a nuclear warhead until it hits? And so there's going to be a lot of controversy about these. There have been DoD programs to do it. There have been congressional blockages of those. So it's an interesting area. Now, to get into the kind of weapons, and of course the classic space weapon that anybody that watched Star Trek and Star Wars is space to space. That directed energy is kind of the exciting area. It was a lot of discussion in the missile defense, space-based missile defense here in the 1980s. Microwaves, lasers, and particle beams. The U.S. spent probably $8 or $10 billion during the 80s in this area. Interesting effort. I think it had a lot of political, both positive and, we'll say, negative implications, but it certainly played some role in the ending of the Cold War. Kinetic energy interceptors were much closer to deployment. These are basically a space-based missile that hits another spacecraft, and then space-based missile defenses that use those technologies against missiles launched from the ground. Space to ground is an area that as I said, there's a lot of discussion, but to my knowledge, there's nothing more than studies going on in these. I mean, this was again the sort of Star Trek where the Battlestar is overhead and it fires a death ray and destroys a city or something. And the other one are kinetic impactors, and it turns out if you drop a 10-ton thing from deep in space, by the time it hits the ground, it has almost a kiloton of energy. So these are sometimes called rods from God because a well-directed kinetic system could penetrate maybe even tens of meters of concrete or rock. Ground to space, of course, are the other end of things. Anti-satellite weapons that would be spaced or ground to space missiles and directed energy weapons. The last one is one that, just to note, that a weapon that's long been discussed is that you ruin it for everybody. You just pump up the radiation belts, and then satellites that are just barely designed to tolerate the natural radiation, increased radiation in the Van Allen belts can cause most satellites to fail in a short order of time. The other big issue here, and just is what isn't a space weapon, and this has caused a lot of consternation. These are the force enhancement systems, the communication systems, GPS systems, and so forth. Information operations is another big area of being able to use space and space communications as a part of information operations I could give you a whole other talk on that because one of my final jobs in the Air Force was briefly the Minister of Propaganda for the Defense Department. Wasn't called that. But, and of course, you know, ICBMs are certainly, they fly through space. One of the key questions, and I don't really have any answer to this, but if the gun sight's in space but not the gun, is that a space weapon? And that's one of the things that is in any arms control discussion gets into there. As I said, there's a lot of interest in defensive counter space. There's efforts of doing things like boxes that you could put on there that would potentially stop deliberate jamming, or warn of somebody approaching you, or warn of interference from the ground. And there are people that believe in, you know, little escort nanosatellites and microsatellites, which is something Ames does do, by the way. Frankly, most of these things, when they do cost analysis, don't make a lot of sense, but you'll see at least continued discussion. These things are being looked at now, and particularly in light of the Chinese experiment here of a year or so ago, there's increased effort in these areas. One of the key issues, of course, is we do more and more efforts to do on-orbit servicing, and there have been efforts. The DoD did something called the XSS-11, and NASA tried to do something a few years ago, but since they did it at Marshall, it didn't work. Ended up impacting the target rather than rendezvousing nicely with it. So maybe we did do space weapons then. But at any rate, these things obviously are, you know, how do you tell that something that's designed to service or interact is not a space weapon? Now, during the 60s to 80s, there was a lot of efforts. In fact, both the then Soviet Union and the U.S. Deployed for a time missile systems that would be launched from the ground. These things, potentially when they impact, could produce a lot of debris that potentially causes more harm than good. Both of these have been discontinued, but again, it started a lot of the discussion.
They were tested.
Yeah. They were tested, yeah, and they were operational. Recently, this has kind of come back again. The Chinese did a series of tests culminating with the destruction of a weather satellite here about a year ago. This caused a lot of consternation in the U.S. defense community. It also produced an awful lot of debris that again exhibited the problem. The U.S. did something this year. I'm not sure if you want to believe that they did it for the reason they did it, but you know, I'll just state that they claim there was a spy satellite that had a bunch of hydrazine on board, that if we didn't shoot it down, it would come down and, you know, kill millions of people or something, so they shot it down. Whether those were connected or not, those are for you to judge. But the problem is this did raise, again, that both China and the United States have an ability to remove a satellite in space. Electronic warfare. This is something that is very hard to tell whether it's a space weapon or not. The U.S. does have something it briefly declared operational, a sort of a jamming system, counter-communication system. It had some other systems designed to optically jam spy satellites. Those were terminated by the U.S. Congress. There have been numerous instances of jamming not by the United States. In fact, Indonesia and Tonga had a satellite war where they used various communications dishes to jam the other one's satellites. And non-state actors, the Falun Gong seized control of some Chinese communication satellites. So it was kind of an interesting effort. So just to point, that's another area to keep. I don't want to talk a lot about missile defense, but other than pointing out that a missile defense system clearly has some space weapons capabilities. A few years ago, there was something called the N-Fire, which was designed to be kind of a surveillance system, but also initially was supposed to be able to, in principle, impact something. And then they said it wasn't, but they still called the vehicle a kill vehicle. By the way, this vehicle now sits over at Ames. We are taking it apart and using it for lunar exploration. Will's been quite excited about that. That it's, you know, it's swords to plowshares. Force application, again, lasers. There was a lot of effort in the 1980s and 1990s. We have some large facilities. Arguably, the Russians launched something. If you talk to people like Rold Sagdayev, he says it actually was a laser, and that Gorbachev ordered them not to turn it on. This again is one of the great mysteries. There's a lot of articles about it. You might have some thoughts on that. So, but the rods from God, again, I don't want to get into a lot of effort other than saying there's a lot of hypersonic vehicle development that is certainly relevant to high-speed kinetic impact that's going on a number of places. High-altitude nuclear burst, when we did test in the atmosphere, as did the Soviet Union, inadvertently knocked out a whole bunch of satellites. So we learned that this is a bad thing. There's a fair bit of effort how to mitigate those. There's actually a facility in Alaska that was designed as a way to, if you could diddle with the magnetic field lines, you could help drain the poison from the wound, if you will, by accelerating the natural processes to cause decay of pumped radiation belts. These are just sort of my points kind of in closing. I think there's a lot of rhetoric. I don't know how much of it is warranted. I think that the space weapon zealots, at least in the last 6 or 8 years, talked too much and did nothing. And I think they scared the animals, if you will. But also, I think some of the alarmists enjoyed being scared. There's a small cottage industry in Washington, D.C. of a few people that collect money and write things on this. So again, I don't know whether this is a big issue or not. Space control is clearly a subset of a lot of other security efforts. I don't think that weapons, when you go through them in space, make any cost-effective sense. And I mean, that's, again, a topic for a couple hours discussion or some over a beer. But I am not an advocate of really any of these things other than space situation awareness and some defensive efforts. In fact, the U.S. is certainly not doing very much in this. I'd suggest that if you add it all together and what we call the space weapon, you're in the tens of millions of dollars of mostly research money. Although that does lead back to the first one. There's a lot of nations developing dual-use capabilities to do things in space that could be used as space weapons. And I think there's a big need in this area for rational dialogue, and I think we're going to see that with the new administration. So it'll be an interesting discussion. Dr. Marshall.
It was interesting that my slides are black and his are white, and sort of historically it's been the other way around. So we made progress. Both sides, yeah. So I just wanted to talk a little bit about ways forward mainly, rather than dwell on the discussion of space weapons per se. Talk about what are constructive ways forward, which was something I've been thinking a lot about because I spent a lot of years trying to argue with people that were advocating space weapons as opposed to trying thinking about alternatives. And then I decided that it might be useful to try and think of alternatives that address some of the genuine security concerns that were motivating the discussions behind space weapons. So let me just talk about some of the initial motivations and then some of the ways forward that I have in mind, and a brief discussion about space weapons in conclusion. So the first thing that is not often known in the public and even in the space industry on the civil side is just how important space is for the military in general these days. And one only needs to think about Iraq to have a very quick understanding of how important space is. Not only was it involved, of course, in the decision to go in, both in reconnaissance sense and signals intelligence, whether or not that was a right decision or not, one can argue about. But it's certainly the case that satellite intelligence was used as a central part of the basis of deciding to go in or not. The entire military operation was conducted from Florida, which is, not possible, of course, without communication satellites. And then everything was, every personnel, tank, ship, plane, etc., and even missiles were guided with GPS. And so they're a central part of the nervous system of modern military. And arguably that doesn't even touch on the most important military space capability, which is early warning of missile attack, because this didn't relate to that. So satellites provide the first warning of nuclear attack on the US and other countries. Russia has a system, for example. And so the basic point is that space systems are very important to US security and other nations' security. It's growing in importance. The US and Russia are the big shareholders in that, if you like, but increasingly many other states are figuring out that it's useful to use space for military purposes, and I'm mainly talking about military purposes that are passive, like transparent things like spy satellites and communication satellites and navigation systems and so forth, because it enhances their military as well as their civil society in an economic sense. So, and a significant problem with this is that satellites are very vulnerable to attack, and this comes from the very simple starting point of the technological asymmetry associated with space. So satellites are very easy to see, and they're very predictable in terms of their position. And they're easy to see. You can literally go outside with a telescope. I mean, with the naked eye you can see them, but with a telescope and a stopwatch, you can pinpoint exactly where as they pass a star and determine their orbit to quite good precision. So, I mean, compared with other military domains, it's incredibly transparent. Everyone can see whose satellites are up there, despite NORAD's efforts to pretend that some of its satellites aren't in its catalog and therefore don't exist. Everyone can see them. You have amateur satellite watchers who regularly predict the positions of NRO totally classified, don't exist satellites. So it's very ironic. It's a very transparent domain. But because they're very visible and very predictable, they're very easy to target. And so that's why ground-based anti-satellite systems and space-based weapons have, to some extent, come to the fore. This, in combination with the fact that they're very important for the military, has driven people to think, oh my God, satellites are important and they're vulnerable. We better put weapon systems into space to stop that. And the sort of irony is that weapon systems don't advance the security at all of these satellite systems, but nevertheless, that is part of the motivation. And so addressing that motivation is an important thing. So in this book, the Space Security Index, we talk about that sort of definition of space security, and I talk about space security mainly because it's a broader concept than just about the space weapons. One is interested in securing the space environment so that for everyone's use. And this is really a note that I make because I make these sort of presentations to generals and people in the Pentagon and policymakers and stuff, and generally it seems to me that people in charge of these discussions don't seem to know Kepler's laws and the rocket equation, which are so fundamental to having a discussion about this that I can't even begin to explain how stupid it is that there are yeah, okay. Moving on then. So what are some of these vulnerabilities? So I sort of tried to list these in order of most likely at the top and least likely at the bottom. So it's very easy to jam, and basically jamming of satellites happens quite regularly, both inadvertently and purposefully, because it can be done with very simple equipment on the ground, doesn't need any space-based systems at all. Physical attacks on ground stations, the next easiest thing. Lobbing a bomb over a ground station, onto a little ground station is very simple because they're on the ground and easy to access. Dazzling and blinding of satellites is remarkably simple. In fact, you can dazzle a satellite with a laser pointer like this if you could possibly pin it exactly onto the place that the satellite is. For optical reconnaissance satellites, the amount of light that you need from the ground is very low, and what that would do is it wouldn't blow up the satellite or anything, but it would mean that it couldn't see this region for that point in time. You'd have to have good pointing accuracy, and my hand wouldn't do. But I mean, in principle, it's a very low power system that one needs for that. And then radio frequency weapons can be used I should first say, blinding really involves when you burn the sensors, and that requires a bit more energy than in this, but not much actually, funnily enough. Because they have these big collecting areas focusing all this light onto one small little CCD array, and so, of course, you don't need much energy to burn it. So radio frequency weapons are so basically the same in the radio band, and heat-to-kill weapons are basically you heat things up via high-powered microwaves, for example. Pellet cloud attack. So all of these things have not involved doing anything in space, but yet they cause vulnerabilities for those satellite objects. I mean, you didn't have to send anything anywhere. And then these ones start to involve something into space. So pellet cloud attacks means you throw a pellet of small metal objects into orbit, and they slowly hit other space objects. That's very simple. With all you need is a LEO capability, or even a suborbital capability. Attacks on space by microsatellites, heat-to-kill anti-satellite weapons. Hit-to-kill anti-satellite weapons we've talked about. That's what the Chinese and the US recently did. I call it an anti-satellite weapon because that's what it is. They call them tests and actions, which is very odd to me. I mean, I call it an anti-satellite weapon because anti-satellite stands for anti-satellite, and that's what they did. High-altitude nuclear detonations is sort of the worst thing you can do, and that was done, but not many people have the capability because you both need a space launch capability and a nuclear weapon, and that quickly rounds it down to only a few states. So, and there's another problem, and that's the debris. That's just the stuff we know exactly where it is, by the way. That's the stuff over 10 centimeters in size, of which they amount about 12,000 objects. There's about 30 million pieces that we estimate in total of man-made debris, most of it smaller than 10 centimeters in size. We track the stuff that's bigger than 10 centimeters because we can see it with ground-based radars, but we can't see the smaller stuff, and yet it's only things above about a millimeter or a few millimeters that can start to have damage on space objects. A lot of this space debris was caused by all of the launches that have happened to date, about 2/3 or 3/4 of which were Russian launches, and but a lot of it was caused by breakups and anti-satellite events in history. And so we can't really carry on with that. And so I've already described this, but this Chinese ASAT event really made matters a lot worse. Although it only it created about 3,000 bits of debris, it considerably increased, according to our analysis, the conjunction rate. So because it goes up with n squared, it doesn't go up with n, and so you only need to add a bit more debris, and it gets considerably worse, your conjunction probability. The US ASAT is less debris, but it's still bloody stupid. Ways forward, let me get onto that. I think one has to really break it into two aspects, technical and diplomatic. This is much more controversial than this, generally, because some people don't believe law does anything. And I say to them, well, aren't you glad there's a law banning murder? And it's a very philosophical thing. Some people like law, other people don't. But anyway, technical measures are much more appealing to most, and so it's interesting. Some things that we've talked about protection of satellites. A lot of people agree that we should protect our satellites more. Space situation awareness, that means sensing where everything is. That's a really good idea, especially sensing smaller things so that we can see the potential for collisions even with these smaller objects. That's very important. And it's good that if other countries do this, not just the US and Russia, which have systems for this, because it's a transparency building thing. Everyone knows where everyone is, and it builds trust. Operationally responsive space is something that has recently caught on a lot in the US military. This is being able to launch a satellite quickly if one of them is taken out, which is good because that means that you're not so worried about people taking things out. However, I argue that there's a couple of other things you really need, and particularly this fourth one, which is about if you really want to deter attacks on satellite assets, what you don't want is a few big satellites that are easy to see and everyone knows where they are, and if you take out one, the system goes down. That's the situation we currently prevail in for most satellite systems that the US has. For example, there's 4 to 6 big spy satellites, and you take out one and there's a big hole. Or there's 4 to 5 early warning satellites against missile attack. And you take out 1 or 2, and there's a big hole over a region where you can't see nuclear attack anymore. What I think that a big part of the future is about sort of having multi-tiered satellite constellations, lots of little satellites replacing those few big ones, so that they're all over the place, and there's no incentive to take out a satellite like the Chinese did of their own, because if you took out one of these small satellites, the system wouldn't die. I mean, the system remains there, whereas if you take out a satellite right now, not only is it easier because they're bigger and fewer, it actually significantly affects and deteriorates the system. So I actually wrote a paper about how one can redesign the US military satellite architecture in a way that is much less vulnerable to attack by having these multi-tiered architecture of little satellites everywhere. And again, all on the passive side, I'm talking about. Space traffic management is another thing. So we're coming up to a point where there's, we in space are like we were in the driving realm, say in 1920 or something. People hadn't bothered to put rules on the road about driving on the left or the right and stuff, because that was fine because there were so few people, it didn't make any difference. I mean, you didn't have to decide whether to drive on the right or the left, no one cared. And then at some point, traffic becomes sufficiently dense that you have to decide. It's in everyone's interest, even, even those that really want to swerve around, it makes everyone's interest to decide, oh, okay, we're going to drive on the left or we're going to drive on the right. And obviously it should be the left, by the way. And so eventually we're getting to that point in space traffic, and so we need to define rules of how to do that, and utilize them. And there was an International Space University project on designing a first sort of design of such a system, and I think that's kind of cool. So on the diplomatic side, we're going to have treaties, and sort of less tangible things like confidence building measures. I think that really we need to go towards treaties. In particular, one needs to just prohibit straight out anti-satellite events and other kinetic kill events in space. The funny thing is that people talk about, oh, it's difficult to define these things and it's difficult to verify. Actually, it's incredibly easy to verify satellites blowing up in space. Not only can you tell who did it, because we have early warning systems to determine who shot the missile, but you can determine exactly when it had by backtracking all the debris to its origin point where the explosion happened. And so you can tell all sorts of information about the event. There's no question of who did it or what have you. It's very transparent. And so a treaty has a good basis there, because we can easily say, hey, it was you guys, pay up in whatever manner at the minute. The irony of what the Chinese and the Americans did in the last 2 years in blowing our satellite is that it's legal. And then the Americans try to lambast the Chinese for blowing up the satellite, but actually there's no way they can, because it's actually legal what they did. And so stupid, because of course that shouldn't be legal. And if it was illegal, then we would be able to punish that sort of action. I think that's very important. Confidence building measures, is basically less concrete versions of this. Basically, this was just, I won't go through this, but I basically designed a first cut at what a system like this microsatellite constellation architecture would look like for each one of the current military space systems of the US, and it's the same as sort of applicable to other countries. Of course, it doesn't make any difference. These are just technologies. The basic point is to have the same capabilities but less vulnerability to attack using existing technologies. I also happen to think that it can be done for a lower cost because the US military is very much in the billion-dollar satellite sort of model. Those are the sort of 5 main functions of military satellites that I was trying to recreate, military and intelligence satellites. And here's an example of one for early warning satellites. We would have a MEO and geotier rather than the current just geotier. We'd have more of them, split them up. We'd split up the nuclear detonation function from the missile tracking function, for example, just to be able to disperse the capabilities. Anyway, you can read the paper if you're interested. This is the space traffic management system that International Space University came up with, basically a conjunction analysis and maneuver systems for collision avoidance, generalized collision avoidance. Believe it or not, that's not done right now. For a few things it is, like the shuttle and the space station and something, we look in advance to see if it will hit us another object and then maneuver if necessary. But for most satellites, most of the time, we just let them go. because the chances are kind of small. But the problem is when that happens, it causes much more debris, and then we have a bigger problem to deal with. And so one has to check it at some point. Space weapons, I think if anyone does a serious cost-benefit analysis, comparable with other alternatives, or in fact, I think most space weapons decrease U.S. security, not increase them. In fact, I've never come across a space weapon that increases U.S. security. I think they all decrease it because the U.S. has the most to lose from a space war game in general, because it's the most dependent on satellite systems. I just think provoking space missile stuff is a bad idea. But anyway, I mean, we don't need to go into that. That's a long debate, but yeah, so this is just an example of how, for one of the weapons. So let me just conclude. So I started by saying that satellites are very important, and yet they're vulnerable. That's one of the motivations why people think about space weapon systems. I think there's ways forward that need more focus and attention, both technical and diplomatic. I think finally, with the dying out of this idiotic administration, we will see this one be revived. I mean, basically the entire rest of the world wants to go into this discussion, but the US has been blocking it for the last 12 years. I think that's absolutely against US security interests. But also the technical approach, I think, will be developed further too. And in my analysis, space weapons aren't part of the discussion at all. They're just stupid. Finally, I just left some resources in case people want some further information on this.
All right, just to kick off some discussion, I was wondering if each of the panelists could perhaps just say a couple of words about the greatest changes that you see coming with the new administration. President-elect seems to favor reducing nuclear weapons, yet he's just reinstated a Secretary of State who has shown some interest in developing new nuclear weapons. Perhaps you could each have a couple of words on that.
Well, I think the hopes are pretty high as far as expectations are concerned. There is we will certainly see some new arms control dialogue with Russia on we have the arms control agreement START 1 that expires in December 2009, and there's been actually the Bush administration started some activity making sure that there is a follow-on agreement, and there seems to be a consensus that there should be something done. I think the new administration is committed to doing that. So at least we will see some progress. It is possible that actually the new administration will do a much more serious overview of the policies, and as I mentioned, the nuclear posture review is coming up. But independent of that, I think Barack Obama is on record saying that he would support the goal of eliminating nuclear weapons. And we may see actually, I think that the time is good for some dramatic changes in the U.S. force. It would be difficult, but not impossible.
Well, I think on the space side, the time for doing things is early in administration before you get tied up in all sorts of other things. I suspect that we've already seen a bit of the change in the president-elect's view on civil space. I mean, he's talked a lot about that, and he's talked about national security space. He has made statements in his campaign about supporting operationally responsive space. He's also talked about doing something about space weapons. So I would anticipate this is going to be fairly high on their agenda. The interesting thing is that space is a topic that you can talk to most people about, whether it's civil or military. And it's often, if you can't agree on sort of harder things like economics, you can go do something with space. I was about 6 months ago, I was in Korea, and I was at a conference on IT, and they sort of escorted me to the front table, and I could tell it was sort of a high level thing because they had Sumner Redstone, who's the head of Viacom, By the way, if anybody ever met him, he is an asshole. I think I said that. But he there was a tag at the end of the table that said president, and I assumed it was the president of the company that was sponsoring this. Instead, it was president of Korea that walked in, and you know, he came over to me and you know, introduced himself, and I was, yeah, I know who you are, sir. But it was he did say, I'm going to see your president pretty soon, and I really want to talk to him about cooperation in space. And in fact, they've signed an agreement with NASA, and I think they're going to do a lot. And as these things go on, I could see the new president will find that not just civil, but also national security space and security arrangements will be an area that will pay big dividends in much broader than just you know, the specific space effort. So I look for seeing some very interesting things in the next couple of years, and you know, whether you're in civil or military space. And I think some of the things Will talks about will be very seriously considered.
I don't really know much about the nuclear stuff, but I just found this on the VUMA website. The VUMA space policy was it made a specific statement.
Not that naughty website.
Yeah, thanks. Yeah, Barack Obama does not support the stationing of any weapons in space. He believes the international community must address the issues of space weaponization head on and enter into serious dialogue with Russia and China and other nations to stop this slow slide into a new battlefield.
Did you write that?
Is there any proposals or thoughts underway for getting rid of the debris that's already there?
Well, that's a tough one. There's certainly thoughts. Most of them are very expensive, and sometimes they cause more trouble than they do. But in the past, we've looked at things like, you know, going up with and capturing things and bringing them down. But that's very, very expensive in terms of you know, systems and fuel and so forth. The areas we're most worried about now is actually geosynchronous, which makes it very, very hard. The other area, of course, in very low Earth orbit, it cleans itself over time, although there's a slow rain of things from above. The other thing that was looked at and actually had some promise was to use large lasers, and you actually would then fire at them and ablate material off, and it would slowly come back and it would decelerate them so they come back in the atmosphere. Now, the problem with that one is it's indistinguishable from a laser weapon, and indeed many of the zealots for that were laser weapons people, and so it's a tough problem. I think that most of the conclusion is that it's in preventive activities, and of course we do have a requirement now, which NASA enforces pretty vigorously, of being able to deorbit things. And in fact, that's added a significant cost. I know the Department of Defense objected to that very strongly. I wrote the white papers on that, by the way. But it's just because it adds cost. So, but I think those are things that are going to be part and parcel of this stuff that Will talked about traffic.
Question for you, Pete. You said that you were not an advocate of space weapons now, but that you worked on them in the past. So I wondered if you changed your mind, what caused you to change your mind, and was it that the thought of military input into space was one of the best ways to get funding for it?
Well, there's certainly lots of agendas. The primary thing is, I mean, again, I spent much of my life in national security issues. In the context of the Cold War, space weapons were a much different situation. And this is a highly arguable, but all security is perception. And that, you know, I was centrally involved in setting up the missile defense program, and I believe that the intent, which actually did accomplish much of that, was to change the game enough to give us abilities to do, you know, to defuse the situation through other means. The threat of space weapons clearly got the attention of the Soviet Union, and I spent time in Geneva and spent a fair bit of time in discussions with the Soviets. And I'm convinced that in that period, the U.S. apparent commitment to do space weapons, coupled with our success in Apollo, was a key consideration in coming to an accommodation. Now, again, that's a highly arguable effort, and there's a lot of, we could sit down for hours in that. But in that sense, I strongly supported the effort to develop those things, and I think that was a positive issue. But the Cold War is over. We're back in a multipolar situation. So today, I don't see a lot of benefit from that. We aren't confronted with a world at a hair trigger where you need to get out of that. I think now, as Will pointed out, space is a way to enhance security through a lot of other things. And that in that context, it's space weapons are probably unhelpful. And I really can't see very many ways that they do anything for us. Finally, I guess, and this is the one area that I do disagree with Will on. I think one needs to be very careful about signing bans on things for all time, because sometimes you find that, what you banned is what you might really need. And I'll just give you one example. All of this could be overtaken. But supposing you banned all nuclear weapons, and then somebody said there's a 5-kilometer asteroid coming at us, and the only way we could have done it is to use a nuclear device against it, or a physics package, to use euphemism. And maybe you wished you hadn't done that. So it's just, I think that there are lots of things short of all-out bans that do make sense and that need to be looked at. And I'm sure that the administration will look very seriously at those.
Maybe to add quickly to your point about the space weapons work in the Cold War, and I would say it was exactly the opposite. And the fact that the U.S. space weapon program, the SDI program, had on the Soviet Union was actually to empower people in the Soviet Union who worked on their space weapons. And you showed this slide with the that was only because of
highly arguable.
Yeah, it is highly, but no, it is actually there are documents now and the archival stuff that actually shows very clearly that was not very helpful in ending the Cold War.
That's not a key point. Is that
That's exactly the opposite way. They looked at those things before it happened, and when this whole thing started, actually it made it much more difficult for the Soviet Union to come to accommodation. Well, I studied this stuff. Believe me. I know, but
the fact of the matter is, we did come to an accommodation. We did end the Cold War. And, I'm convinced that part of it was Reagan's refusal to give it up at Reykjavik, and that opened some new channels. And we have our own sources and our own information. Yes, indeed, they tried to compete with us and lost. So that's an exciting, interesting discussion. I mean, I've written a book on it as well, if you'd like to read it. And but that was then. This is now, and there's a different situation now, so I think we're probably in pretty good agreement. No, it's a different situation.
So, Pete, you started your talk with a bunch of definitions, and Will, you alluded to the diplomatic problems in the past. I mean, one of the things that we need to define is space, and as I understand it, we've been sitting over there in Vienna for more than a decade arguing about what space is in order that no one can have anything to say about what our assets are there. Are we likely to see a change in that attitude along with everything else? It seems like it's a first step for the next administration.
Space is still not defined in the context of the international legal system. But on the other hand, there's a very strong consensus that it's basically 100 kilometers and up, and it doesn't necessarily have to be orbital. It's just a space definition. But that's not to say everyone agrees with that. And yeah, it would be useful as a starting point. Part of the problem with these ASATs is that it's very much altitude dependent. I mean, and it makes a huge difference whether it happens at 80 kilometers or 800 kilometers. And so, yeah, I think your point is very important, and no, it hasn't been addressed. But I mean, there has been belligerence on the part of the U.S. in this system. I mean, I've been to Geneva through these discussions. I've been to Vienna through these discussions, and they are, it's really, there's no other words for it. It's the U.S. and the entire rest of the world, it's literally 167 votes in the GA4 of resolution to go forward with a discussion on space security and space weapons, and 1 against. And, that's the US. And, I mean, that boggles my mind that the US is like, so belligerent on the issue, but I think that's just about to change.
I have a short question for Dr. Podvig. You said that the Chinese started out with ICBMs, but that would have been at a time when their main enemy was the Soviet Union. Why would they have wanted ICBMs at the time when their main enemy was close by?
No, well, I think that still if you want to go from China to Moscow, you still need a fairly I'm not sure that you need ICBM, but I think it's when you start doing that, I mean, at some point you do need the two-stage large missile, and you may as well just go for an ICBM. And they did keep the United States in mind as well, I think. So that was, I think, that was political, but as well as the engineering decision.
Yeah, I have a question back here. Can you explain the rationale for the number of the missiles? It just seems like countries other than U.S. and the former Soviet Union have the appropriate quantitative strategy for self-defense and even offensive capabilities. Why the order of magnitude difference? And that's one question. The other question, out of curiosity, is who is leasing the submarines to the British? And third last question is, if you believe that taking out satellites is so easily done, why didn't the Iraqis prepare for that during the war? Okay.
Let me on the numbers. The only reason these numbers are that high is that because that's what we did during the Cold War, and if you look at the kind of at the arguments that people made in favor of those numbers, you could say that, and hindsight, they didn't make much sense, in fact. And it was.
I want to answer this, but that's not correct.
It was a complex process, and certainly people were making arguments and the rational and irrational as well.
Quite rational strategy. It's not mutual assured destruction.
Well, that's
which wasn't the U.S. or Soviet strategy. It was a nuclear warfighting strategy.
Basically, they were trying to take up all the different bases. So
yes.
They wanted to be able to.
That was certainly one of the. That was
our stated strategy.
One of the
one of the myths of the Cold War.
Yeah, that was certainly one of the ideas, but there were other people who were arguing other ways. So that's but the bottom line, I think, at this point, it doesn't really make much sense to keep those huge arsenals around. On submarines, I think the British, they have their own submarines. They just they lease the missiles, and those are actually U.S. missiles, and they are actually U.S. property as far as I can tell. And they
the British have their own submarines and the two warheads, but they use
use missiles.
Same missiles that the U.S. use on their subs.
And
sorry?
It is unusual.
Yeah, well, maybe I can. Not that all these things make sense, but the issue was the Trident missiles are U.S. manufactured missiles, and the point is that various agreements, we don't sell strategic things to other people. In fact, there are even agreements that we don't do that. So you can lease them, which is a different issue. So the point was that rather than the British building their own missile, which they didn't want to do, they leased the U.S. missile to put in their submarines. And it's kind of an artifice to say that, if it would have been a tactical program, they would have co-produced it, or we would have sold them to them or something. But this had to do with a lot of agreements that we had, even some of the arms control agreements. It was kind of an artifice. Although in the arms control negotiations with the Soviet Union, they always counted the British missiles, but not the French, as part of the U.S. force. So in some sense, they were accounted for in those numbers. So they would always add the British force. The British didn't like that, but the fact that they were our missiles, and, that presumably they would fire them if we asked them to. Yeah, that's right. If you use it, then you have to pay us for don't return it.
What was the third question?
Oh, that's
Well, actually, they did try. I mean, they had GPS jammers, but they didn't have any way to launch anything in space. So but they did actually buy and try to use a number of GPS jammers, but it was a fairly unsophisticated jamming system that was not effective.
And sexually, it's not an easy thing to do, because I mean, although we'll have this point that if you have a system that is distributed then it takes a serious effort to take it down, and GPS is that kind of system.
It's at a high altitude as well.
Yeah,
it's at high altitude. But let me just comment that there's a couple of factors involved with Iraq. Firstly, it's sort of on the borderline as to whether it has the technological capabilities. I'm saying easy with it's a relative statement. I mean,
for Britain, because they would buy it.
No, right. Not under my regime, they wouldn't. So they're not that easy, and basically there's about 20 countries that have missile capabilities that would be the central essence of a system to do an ASAT. Iraq is sort of on the borderline of one of those countries. It's not quite got that suborbital launch capability, basically. The missile to get you up there. And whoa. Yeah. So for different systems, yeah. I mean, but one also has to remember that there's different levels of. I mean, there's not that many people in Saddam Hussein's tight regime that understand the basics of space properly. I mean, it's just like a limited number of people in the decision loop that have any competence associated with this. I think it's just a very, yeah. No, but I mean, Stanford's got more chance of launching an ASAT than Iraq, in my opinion. I mean, it's just like a concentration of people that have got enough education. Caltech for sure. Yeah.
Even the University of Alabama at Huntsville could probably.
I have a question about international trade in weapons and weapon systems. I once heard a talk a couple of years ago by George Shultz, and he prefaced his talk with a little blurb about how important free trade was in general, and then gave a very nice talk on his work on arms, on nuclear proliferation work. And it struck me there was a little bit of an ironic tension between those two parts of his talk. And when I asked him about it, he didn't seem to have a clear answer. My question to you guys is there some line between ordinary weapons of small amounts of destruction and big weapons where free trade is not allowed, or trade in general shouldn't happen?
That's an interesting question, but I think eventually the point is that certainly the free trade creates a lot of problem in the for non-proliferation regime, and we've seen the EcuCon network when they were able to order some parts in Malaysia and ship them. So that creates a problem, but I don't think that in itself it creates the situation in which countries would want to buy or even want to own nuclear weapons, and so I think it's harder to manage, but I think the net benefit is with the free trade, because once you start the free trade development, then you just undermine the incentives for countries to have nuclear weapons, and that's the most important part of it.
Yeah, I think the attempt has been to ban trade in strategic weapons, and then allow it in sort of things that are not strategic. I mean, it's very hard to make that line, and in fact, I think we've overdone that quite badly in space. I mean, in fact, ITAR defines all space technology as weapons, and I think that's a very counterproductive effort. So you have to be very careful on that. On the other extreme, of course, that you can't really call them strategic and tactical. I mean, I remember in the 60s the Army, being aided and abetted by Livermore, was going to develop a nuclear hand grenade. I mean, I don't know where you would use this, but
Pretty good arm.
you have to have a very good arm. I mean, there's obviously, when you start getting into things like that, it gets kind of dangerous, and but I mean, on the other weapon that is the two weapons today that are of great concern are going to be very hard to control. One is biological weapons, as you do, eventually artificial biology, but also genetic capability that is fairly easy to do. The other one, of course, is computer attacks and so on, and those make it very clear. I mean, we can't stop all trade in those, but I mean, the issue is it's bad enough when kids in the basement make computer viruses. When they make real viruses, it's going to be even worse. So those are areas that cause me a lot more concern than the nuclear and space things right now, which are fairly easy to at least deal with. I mean, I think Will's point was that it takes a rather sophisticated group of people, and it's kind of hard to buy it to build satellites and launch vehicles and nuclear weapons. So it's a different issue. I mean, unlike the movies, it's real hard to make a nuclear weapon. And despite what Will says, it's hard to make satellites too, as he's finding out.
Question for Pete and Will. Much of the discussion about space, situational awareness, the weapons in space, space control, etc., seem to relate to nation states. In today's world, we're most particularly worried, I think, about actions by terrorist groups, which would mean what kind of access. My question is, what kind of access do they have, or what are the powers that be worried about as it relates to terrorists and space security?
Yeah, I mean, terrorists in general don't have much access to space stuff, but some of the simpler vulnerabilities can certainly be exploited by terrorists, and we've seen radio jamming by terrorist groups, or like, at least from the Chinese government perspective, Falun Gong is a terrorist group, and they jammed a satellite broadcast of something. I can't remember what it was in particular, but so groups of people that are loosely organized like terrorist groups can certainly interfere at that level. But that doesn't tend to cause permanent damage or anything that's long-lived, basically, to satellite systems. And it's hard pressed for me to think of ways in which they would do it. Say potentially laser ASAT stuff would be within the realm of possibility. Pete and I sort of disagree on exactly how hard that is. He's probably thought about it more than me, so. But I don't think it's that difficult, and certainly in the realm of possibility for those sort of people. But again, like, I'm not trying to. It is about concentration of minds, ultimately, all of these things. And the reason I say Stanford, I'm not trying to suggest that makes, I'm saying by the fact that Stanford can do some of these things means to me it's simple. But that doesn't mean, let me rephrase. It means that, a small group of well-educated people can do it. But actually, a lot of these organizations don't have that. I mean, how many have a few dozen physicists that are trained in laser stuff? Not many at all, because if you're interested in that stuff, you can't get an education there. So you either don't get an education or you move. So I mean, those people don't, they don't have much access to that stuff.
Yeah, I'd like to underscore that. To mount what we might call an anti-satellite attack requires a lot of sophisticated technical thinking, and quite frankly, terrorists, they may have some sophisticated technical people, but most of them believe the last word in truth was written in the 7th century. So, there's a little bit of a concern that it's hard to build spacecraft with that technology. But conversely, they tend to adapt things they can find and use. I think that the threats that we really have to worry about from terrorists are really cyber threats and potentially biological threats. In the space area, I think protecting our satellites, control systems, and so on is probably much more important than protecting things. The other one, of course, is, and I know the Department of Defense has done a lot of work on this, is in the past we had just a small handful of very vulnerable control facilities. And, for example, it used to be all of the spy satellites the U.S. had were flown out of this little blue cube over here, that we could drive by on the freeway and throw a satchel charge over the fence and take care of it. Now that's been fixed now. So there's a distributed set of systems and multiple redundancies and so on, so you don't have that anymore. So that's really I think the answer to it is, it is unlikely that terrorists are going to, build a satellite and launch it and go out and do something. That's not impossible, but, it's kind of hard to stealthily, acquire a large booster and do a countdown on it and so on and so forth and do the command and control. Even NASA couldn't rendezvous with a satellite here when we tried.
So to follow up on that, actually, we'll talk about rational actors, and a lot of your arguments here are about the difficulty of access to space. But we are moving into a regime where it's going to become a lot easier, aren't we, over the next couple of decades? And my question, therefore, given that will happen and that not all actors will necessarily be rational, what's the best way forward in terms of security? Is it like we were saying, it's international treaties, or are there some other options?
Well, on this, I tend to really agree with Will that some sort of traffic agreements, backed up by multiple abilities to know what's going on in space, so you can, again, what stops people from drunk driving? It's the fact that we have laws that we've agreed to, and that we have, people that watch, and then ultimately maybe means to stop things. And so I think those kind of things that his list, I very strongly support, is something you ought to do, that start with that. And I think it's going to happen. And yes, in 20 or 30 or 40 years, when, you have a lot of private sector people being on the moon or other places, we're going to have some sort of, of rule of law and ability to enforce that. And I would suspect that's where these various countries' military forces, just like we're working together now to stop piracy, is going to happen.
I have just a follow up on that. I largely agree, but one of the interesting things about the space domain is that compared with the other domains, is that is this ability to affect to ruin everyone else's day with your action. So when you go out and murder someone here, although that can be really unfortunate for the person you murder, it doesn't generally affect everyone else. Or if you crash your car, it might take an hour to get it off the road and to get out of everyone's way, and then everything's running smoothly again, because we can move debris. So in the case of space, we have an issue that we don't know how to remove it yet in an economically efficient way, as we were discussing based on an earlier question, and that means that I think that means that we have to be a little bit more preemptive in some of these rules, because you can't wait until the traffic gets too bad before you have the rule, because the traffic will then be there permanently, and that's not a good thing. So I suppose my only caution on it is that I think we have to think ahead a little bit more with space, at least until some smart person comes up with an economically efficient way of removing debris, which is conceivably, has these long-term consequences.
A couple of things. The Soviet or the Russian rods from God program or testing that you had alluded to. The second, anything to do with the current status of neutron bombs, which were prevalent in the 70s,
And then the last thing is, the answer to the question was Lend-Lease during World War II, before our involvement, official involvement in the war.
I wasn't aware of any real concentrated effort on the part of the Soviets on rods from God. I mean, I was really referring to a U.S. effort. We never tested anything. There was a lot of technology development work that we were doing, it's important to say that. I mean, I'm sure there was similar analysis done in the Soviet Union, but let me ask.
Well, a neutron bomb, I think I don't know any kind of a program like that, whether in the United States or in Russia. I don't think that's something. On the kind of a Soviet program, it wasn't rods from God. It was this laser, basically a battle station in space, which was actually a very interesting project. And it was not the thing that actually was launched into space. It was lost because of software error. Was not a functional kind of a satellite. It was a prototype, but it did have on board a few systems that were supposed to. There was initially the idea was to release balloons to track them with laser rangers, with the radar rangers. There was an experiment there that would test the exhaust system for a gas dynamic laser on this kind of satellite. So it was actually fairly advanced program. And back to our argument that, in fact, if you look at the Soviet Union actually did got into some efforts to build weapons in space, and in fact it got fairly far. I mean, by the late 80s, when it wasn't necessary anymore, but by the late 80s there were a few programs, ASAT in particular. There was a program that was tested and actually tried. There was a program to deploy those kill vehicles on those SS-19 missiles. They were thinking I remember they were thinking about using them against actually SDI satellites, and I remember I had this conversation with one of the general designers of those systems, and I asked, so you would have just started shooting things down? And he said, yeah, why not? I mean, we were like, so I think there was a program there. I mean, some of that actually is still around, but that was real.
I might have weighed something like 110 or 120 tons, which is about half the mass of the International Space Station. It launched on one launch. The first launch of the Energia rocket, which then the second launch was the Buran shuttle, basically a copy of the shuttle. It was sort of upgraded in several key ways. It was kind of cool, but unfortunately it was the only ever launch of that Buran system. But the first launch was this huge military payload. It was just 120 tons. Incredible.
What was your question on Lend-Lease? Oh yeah, with the British, yes. Yeah.
Well, if you'll join me in.
Before you wrap it up. Just on behalf of the SETI Institute, I want to say thanks to our panel. You've actually helped us explore one of the factors of the Drake equation, which is something we founded the SETI Institute around, and of course the factor L, the longevity of a communicating civilization, has a lot of dependency on what we talked about today. So on behalf of the Board of Trustees, I want to say thank you, and then I'll turn it over to Adrian to close out the program.
Well, if you'll join me, ladies and gentlemen, in thanking our panel for their great input today.